Here's your chance to take notes really, really fast. Those that got their notes last time, you guys can chill just for a bit. We good? So we are on something called Chapter 3, Radian Measure. Radian Measure, Radian Measurement. I think it's just Radian Measure. So remember if we had degrees. Cool, cool. And so, okay, hold on. With degrees, we did have like decimal degrees, is that right? And then we had what else? Degrees, minutes, seconds, right? So for degrees, there's kind of two different ways we write them. Good? This will be a totally different way of measuring stuff called radian measurement. Whoa. Good or bad? I said you were dreaming, so that's...
It wasn't bad.
Okay.
It wasn't like a math nightmare. I woke up and I was like, oh, I don't understand how... What was it? It was like my mom... Were you doing math? It's like applications. Like my mom was like talking about something, and she was like, it's like this many degrees a minute. And I was like, oh my gosh, we did that in math. Yeah. Oh yeah, my brain's a scary place. Yeah, my sister said it.
All right, class, let's begin here. Let's see. This is 3.1. It's called reference angle. And I'm going to go just real quick here. Those that were not here the other day, let's jam with it here. So, name the reference angle. This will be super fast, not the whole entire lecture, but this will be a sort of quick lecture of it here. So name the reference angle. So what is a reference angle? We're going to do some notation as well. So let's go with this one. Let's start off in order. I like this here. So we're going to go like this. Quadrant 1, super fast. I'm going to go 60 degrees. Remember, we have to put the little ray that comes out from the origin. We have to put our little, what do we call that here? What should we call this little guy? Our squiggly arrow? No, our rotational arrow? Maybe our rotational arrow, that kind of makes sense? So in quadrant 1, so what in the world is a reference angle? The reference angle is the angle that goes from the x coordinate or the x-axis to the angle itself. So those that read already, you guys know this. Oh, Mr. Renji, you already know that here. So this guy is called theta, and in quadrant 1, so theta is 60 degrees. So if you just measure from the x-axis to the angle itself, how many degrees? 60 as well. But we do have a little difference of naming here. This little guy is called theta hat because it kind of looks like a cool little hat. So in quadrant 1, we have this. The angle measurement is exactly the same as the reference angle. Are we good there? Super fast? Make it. Yes. See it? Absolutely. So then we go on to B. So what happens if we move into quadrant 2? So I'm going to just kind of put something in here. 135 degrees is good. My ray, my rotational ray, and the angle itself, 135 degrees. Question is, what is my reference angle? What is perfect? It is the angle that's still getting to 180. And so let's go back over here. So in quadrant 1, actually, let's go here. One more thing. In quadrant 1, the reference angle is the exact same thing as the angle. Cool. We go to quadrant 2. Let's see. If I'm at 135 degrees, how much more do I need to get to 180? I need 45 degrees more. So if that is 135 degrees, reference angle is 45 degrees. And what is the equation for the reference angle in quadrant 2? It is 180 degrees minus 135 degrees in this case, but theta would give us our reference angle. Are we good there? Again, really quick, super fast review of, and then she showed it. And so we got C on our hands. How about quadrant 3? Quadrant 3, I'm going to pick something in quadrant 3. I'm going to pick 210 degrees. Like that. 210 degrees. So my theta is 210, but my reference angle is 30. So in this case, we were talking about how many degrees have we passed the 180. So notice the reference angle always ties back to the x-axis. So in this case, what's my formula? Cool. In this case, it's theta minus 180. to get us that. Oh, and I forgot. And the reference angle here is 30 degrees. Are we good there? Super cool, super cool. Next is D. Sorry, let me go back to see. That was a little too fast. Okay, so far so good. You guys talk to me? Cool. D. And then we get into quadrant 4. I'm going to say this guy is 300 degrees. So theta is 300 degrees. The reference angle, someone said, is 60. How did you get that? Yeah, so it's the gap that is between the 360 and the 300, which is 60 degrees. And the formula for it would be theta hat is equal to 360 degrees minus your angle itself. We good? Cool, cool. Okay, so now let's jump to some other stuff. Okay, now this one may be new. You guys ready for this? And then, okay, so we went to some other ones here. So how about if I do this here? 152.5 degrees. What is my reference angle? This time it's good to use the formulas now. So if I'm here, I'm in quadrant 2, is that right? Here, 152.5 degrees. And this time you probably want to use a little calculator, or you can do it in your head. That's kind of cool. But you're saying I'm going to do this. I'm going to do 180. Is that right? Degrees minus 152.5, and the answer for that is 27.5 degrees. Cool. Okay, there's one. Say again. Oh, awesome. We'll get there in just a bit. The reference angle? Oh, interesting. Gotcha. Okay, cool. Yep. Okay, and the other one here. So there's that one. Then let's go above. Oh, hey, how about this here? What is my reference angle? Anybody? So this one's new. Did not ever done this before yet. So anybody, 595 degrees, I need to know the reference angle. Okay, oh, that's right. 25. Okay, so 9. Oh, wow. 55, okay. Let's go with it here. So I'm going to go, first of all, if I'm going to do this manually, got 55? Let's go with it. So if we do this manually, right, and visually on the context here. So this is 0 degrees. That would be 90 degrees. That's 180. This is 270. We jump to 360. Add another 90 here. We get, what's 360 plus 90? 450. Add another 90. 540. Is that right? The hundreds digit goes up and the tens digit goes down. That's all we do, right? So there's 360, then it goes 450, then it's 540, and then it is 630, and we've passed it up. So now we know we are in quadrant 3, somewhere in quadrant 3. Oh, here's our little rotational when it goes like this. Wee, wee. We're good? It's, do that for longer. Okay, but now computationally, how do we do this? We take 595 and we subtract 360. Anybody tell me what 595 subtract 360 is? 335? 235. Okay. 235 is cool. Okay. So now we know in quadrant 3, so that means the reference angle is going to be, since we're in quadrant 3, it is going to be theta minus 180. Is that theta minus 235? Is that right? No, it's going to be cool. Okay, so it's theta minus 180, right? So notice theta has to be between 0 and 360, right? That's kind of where we have to be. So let us subtract that out. And 235 subtract 180 is 55 degrees. Okay, that's one interesting way. We good? Oh yes, coterminal angles. Yeah, 595, Yeah, isn't that funny? Because we say this and we say this. Is that true? That is a true statement in regards to an angle measurement. Yeah. Cool. All right, and one last one here. We kind of covered it last time. I didn't. Oh yeah, this would be cool. How about a negative angle? Just trying to confuse you guys. Anybody with a negative angle of 215? It's not a repeat of the notes. Oh, cool. Okay. So we have a negative angle on our hands. We can think about it as a negative angle going this way backwards, right? So we got 0 degrees, negative 90, negative 180. Is that right? And once we go over here, we go negative 270. We just went too far. Is that right? So now we know we are in quadrant 2. Da, 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 da. And then Holden said, you know what, Mr. G, if this is so easy, how about if we just do this? We just take negative 215 and we add 360. We add a positive rotation over here. So what is a negative 215 plus 360? 145. Now, is this angle between 0 and 360? Absolutely. And now we go this way. Oh, interesting. So we got this right here is our negative 215, right? Oh, but technically we could just do this as well. That is still the same thing as a positive 145. And since we're in quadrant 2, our reference angle is 180 minus theta, 180 minus 145. Anybody with an answer here? 35. Okay. All right, the 3 people that were absent, should we, okay, the rest of the class, should we show the video? We should do the video. The hand trick in trigonometry. Okay. What? There's some cool stuff. Yep, it's, I don't know. So, yep, we got to find out. So let's do this here first. So Caitlin's question was, why do we do the reference angles? Because instead of memorizing the whole entire circle and all the different values, so here's what, just to torture my high school kids, I used to have them do the whole entire unit circle like this, and they had to tell me at 0 degrees what's my x and y coordinates, right? Because this is my cosine value, is that right? And that's my sine value. And then I need to do 30 degrees, 45 degrees, 60 degrees, right? And then each one of these has, let's see, what's this one? This is going to be root 3 over 2, is that right? 1/2. And this one is root 2 over 2, root 2 over 2, awesome. And this is 1/2, root 3 over 2. And this is, and then you notice when we go over here, notice what happens. It's a repeat of the stuff in quadrant 1, except the next is a negative. That's about it. So we go here, notice the same exact values. It is a negative 1/2, right? Root 3 over 2. It is a negative root 2 over 2. And a positive root 2 over 2. It is a negative root 3 over 2. 1/2, is that good? And this guy is a negative 1, 0. And then we go to quadrant 3, what happens here? Yeah, both of them are negative, but it's still the same exact values. Is that right? And then we get over here, this is going to be 0, negative 1. And then we go over here, what happens here? The y is negative, x are positive, and we get back all over here. So really, as long as you know these right here, as long as you know quadrant 1, you have the rest, which is really just the reference angle. Is that right? So if you guys see on your little chart on the last test, the chart that is given usually for trigonometry, let's see if we can find it real quick here. Downloads, no, not the downloads, it is this one here. So see if I can find them. I don't have, do I? Yeah, reference chart, there it is. So all trig functions, they in most trig textbooks, what they have all the stuff defined. Oh, there's sine, cosine, tangent, cosecant, secant, cotangent, and they only define it from 0 to 90, because once you know these, you know the rest of them just easily. We're good? So now the question is, how do you find these out easily? And so last time, Adrian had a nifty idea, I'd like to share since he did, so we've got to do it. So we do quadrant 1. 1, 0 was here, right? And so this is just quadrant 1, right? Think of that little piece right there. And so we go to 30 degrees. 30 degrees is root 3 over 2, 1/2, right? And then we have root 2 over 2, root 2 over 2. Notice there's enough of these, we're going to memorize them just by writing them out so many times here. 1/2 root 3 over 2, and then we get to 0, 1. Okay, so then that's kind of interesting. So we have this little guy is root 3, right? Then you have a root 2. So it couldn't, hey, isn't a root 1 really just 1? So you could actually write it even like this if you wanted to, right? That would be that. So then how do you get a 0? Oh, it's just root 0 over 2, is that right? Okay, so then hold on, how do you get a 1? So this is 1, root 1, this is root 2, this is root 3. This should be root 4 over 2. But what's the square root of 4? 2, and what's 2 over 2? 1. Interesting. So really this could be written as super cool stuff. Dun, 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 dun. This could be written as root 4 over 2, right? This one, going over here. This would be root 3 over root 1 over 2. Everybody agree there? Oh, sorry, no, I messed up. Let's go backward. Love it. This would be root 0, right, over 2. So 30 degrees, boom, is going to be root 3 over 2, root 1 over 2. Cool. Next. Oh, these are the same. So whenever you have a 45-degree angle, you know it's a root 2 over 2, right? You just need to know which quadrant you're working with. Okay, so this is going to be root 1 over 2, root 3 over 2, and then over here, it's going to be root 0 over 2 and root 4 over 2, technically. We good? Awesome. So as long as we know those, we're good. So one way to memorize it is whenever, this is my way kind of to remember, I know this little dot is going to be 1, 0. So now cosine is the big one. Sine is at 0 at this point, right? So then I know I go down for cosine. And then from the 90 degrees, I go up for sine. We good? That's the easiest one. But we have a video. Da, 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 da. So how do we get these little things right here? So this is the da, 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 da. So the exact trig functions using the hand trick. Ah, we were watching this in a financial literacy class. Oh yeah, we're catching music.
Hi, I'm Lucy, and in this second part video, I'm going to show you a hand trick to find those exact trig values that you need to know. So the angles from part 1 were 0, 30, 45, 60 and 90. We're going to use those same angles, but a different trick this time, rather than that table of values. Take either hand with your palm facing towards you.
Usually that's the way to go, right? So your what is going to be our left hand then, right? Left hand, I go.
Your little finger is 0 degrees, your ring finger is 30, middle one is 45, 60, and your thumb is 90 degrees. To make this work, you just need to remember to square root the number of fingers and divide by 2. So if we wanted sine 30, we'd bend down our 30-degree finger, and you just have your baby finger underneath. So sine 30 is square root 1 divided by 2, because there's only one finger underneath, which simplifies to a half. If we wanted sine 90 degrees, you'd bend down your 90-degree thumb, and so you have 4 fingers underneath. So sine 90 is square root of 4 divided by 2, which simplifies to 1. What would sine 60 be? Work out the answer and click
Sine 60,
here
go.
to check.
Go there, Joe.
Did you get square root 3 divided by 2? For cos, you just count the fingers above instead of the ones.
I really want to know, in England, if they say cos, that's what they say. That's interesting. Interesting. Okay. Okay. Awesome. Interesting. That is so cool. Oh, awesome. That's so fun. That's fun. Okay, so for cosine, what is
So
it?
for
What was
cos
the rule
60,
is?
bend down your 60 finger and count the fingers above.
It's from the top. So
So
it's the
cos
above
60
fingers.
is square root 1 divided by 2, which simplifies to a half. What would cos 90 be? Work out the answer.
How many fingers above?
Here when you're ready to check.
0 above, right?
Did you get 0 degrees? Bend down your 90-degree thumb, and there are no fingers above.
It's just 0,
So
right?
root 0 divided by 2 is 0. And finally, tan. For
All right, and
tan,
tangent. What? We can do tangent? Absolutely. Here it is.
count
Tangent
fingers,
is?
but there is just one extra little twist. The same as for sine and cos, bend down the angle finger. So let's find tan 60. Let's bend down our 60-degree finger. We've got one cosine finger above and 3 sine fingers below. For tan, we flip our hand over and we have 3 sine fingers above and 1 cosine below. So tan is square root fingers over square root fingers. So square root 3 over square root 1, which simplifies to root 3. What would tan 30 be? Work out the answer and click here when you're ready to check.
Whenever root 3 is correct. You guys got that? Yeah.
Did you get square root
It's always square roots, right? So
divided
it'd be
by
square root
square
of
root
3 on the bottom.
3, which would simplify to 1 over root 3. So there we have a really easy way of remembering those exact values.
Okay, and we'll stop there. Okay, we're good? Yeah, I guess everybody do this right here, right? It's looking over. All right, and then there was a way you guys figured out how to do secant and cosecant. I'll let you guys talk about among yourselves a little bit later on. Anybody show it? Anybody show it to people that were gone? Go. It's kind of like you do tangent, right? It's kind of like you do tangent, but you're still only talking about. Yeah, Katie, go ahead. Anybody tell me what cosine of secant of 60? Here's my thumb. 1, 2, 3, 4. Okay, so we take this finger, we go on the inside here, so now we have 4, and then we flip it, is that right? So hold on, do we count how many above first?
I don't know.
You don't flip your
So count how many above, which is 1 above, is that right? Oh, for cosine is above or below? For cosine it's above, right? Because secant and cosine are related, right? So count how many above? 1. Then what we do is we flip it over, right? And so it's going to be 2 on top, right? But then
Where did the 2 come from? Where is it? Oh. Yeah. Okay, so cosine and Caitlin, cosine is the inverse of cosine, right? So you do cosine 60, flip it over.
Yeah, but this is why
You're not flipping your hand so much.
I'm putting the 2 on the bottom, right? The 2 goes
That's 3. That's 3. You're flipping the fraction, not your hand. That makes so much sense.
2 is on top, then on the bottom, right? It's the square root of fingers on top, right? Fingers above. You just flip the 2 on
I
top.
thought we were flipping our hands, and I was like, that doesn't make any sense. Then that's 3. Yes, okay. So then for the cotangent,
for cosine, it's fingers above.
Yeah.
So if it was cosecant,
Yes.
cosecant,
Yeah. Yes. Okay.
that means it is fingers
Cotangent,
below.
flip your hand and use hand. Below. Okay.
You're trying to give sine. Sine of 60.
Okay. I get it. Sorry. I was thinking that we were flipping our hands, and I was like, that doesn't make any sense.
Okay, so we're done with that. Let's go with it. So just to practice just a little bit here. We're on example 2. Exercise. Okay, exercise 2. Just jam with it here. You guys tell me what are the directions for exercise 2? What was it? Find the exact value, I think it was, right? Find the exact value. Find the exact value of this right here. So cosine of 150 degrees. So let's kind of think about this here. Just for in your mind's eye, think of this here. Cosine of 150 degrees is over here. Is that true? Right? So would this be, negative or positive if we go back to quadrant 1? Yeah. The x values are negative in quadrants 2 and 3. So it would be this. Tell me if you guys agree here. So cosine of 150 is the negative of cosine of 30. We're good. Notice I have my reference angle here, and I just think about my sine, right? Everybody good there? Cosine 30 degrees is? Go, go, go. All right, root 3 over 2 is done. We good? So we go back to the reference angle, go back to quadrant 1, and then we can actually do that real quickly here. So another one. We good? Another one. B, how about sine of 210? Think about where it's at. We are here. So if you go back to, what is the reference angle? 30. And in quadrant 3, is sine negative or positive? Negative. So it'd be negative sine 30, and the answer is? Negative 1 over 2. And let's see if I can squeeze this one right in here. So sine of 300. Sine of 300. Cool. So then we go over here, right? We're in quadrant 4, right? Is sine positive or negative in quadrant 4? We have sine. Cool. So sine is negative of 60. Anybody got that one? Answer is? Negative root 3 over 2, right? So again, going back to your angle measurement here. Okay, so then let's go C, D. Let's go. Tell me if I'm going too fast, I can go back. Cosine of 300. Think about this one here. Well, that's positive, right? Because remember, cosine is positive in quadrant 4, right? Reference angle is 60. So positive cosine of 300 is positive cosine of 60, and cosine of 60 is? Yeah. 1 over 2. Boom. Okay, and on our formula sheet, you're going to have this right here, right, on the formula sheet. So you can reference this, right? Because that's why we only have 1, 2, 3, 4, 5 angle measurements, right? So you don't have to do it in your heads. Don't have to do it with your fingers. You can look at the chart. But if you want to do it with the fingers, because it's kind of cool. Exactly. Okay, so those are angles we know, right? Any multiples of 30, any multiples of 45, we know, right? Okay, and then one more. We should do one more here. So that's D, E, E. Notice if you guys see a 5 anywhere, you know it's a 45-degree angle. So I see 225. Oh, not 222. Once you see that 5 there, you know it's a 45-degree angle. You just need to think about it. We are in quadrant 3, sine negative positive here. Negative, so you negative, sine of 45, and cosine of 45, sine of 45, they're exactly the same. So 45 degrees are the easy angles to deal with. Okay, next, get out your calculator. So those are all the angles we know how to do manually, right? So now let's go with angles that we have to use a calculator. So use a calculator to find the following, most likely. To find, that's supposed to be a D here, to find the following. Okay. A. Okay, start off, let's go with the sine of 133 degrees. Perfect. Okay, I'm going to get my calculator out just real quick here, just so we know. So first things first, if you guys can, go with your calculator and go to your mode button first. There's your mode button right over here. Boom. Click on that, and just to make sure, see, mine always goes back to radian measurement, because radian measurement is the default measurement that we're going to use eventually, but you guys have to move it over with your arrow keys, go down 2, 1 to the right, and click enter. So make sure you are in degrees. If you're degree mode already, that's cool. You should have that right there. You should have normal, float, degree, function, connected, sequential, real, full. Okay, are we good there? Okay, now we're ready for trig function. So second, and click the mode button for quit. And we got ourselves sine of 133 degrees. Oh, do we need to put a degree symbol? No, we just click on it because we're in degree mode already. So 0.73, and usually we go about 4 decimal places. So 0.7314, are we good? 0.7314, done. B, tangent of 105.7 degrees, go. 205.7 degrees. My speeching ain't matching my writing. So 0 4813. Okay, cool. Oh, this would be a fun one here. How about tangent of 89 point, oh, how fun, 98 degrees. Ha ha ha. That's crazy. Let me do it on mine over here. What tangent of 89.98 degrees is a big number? Whoa, crazy. Just 4 6 figs, yeah. So 2,865 would be just fine. 2865, 2865. So tangent actually gets ginormous. Is that right? Whoa, that's cool as it gets closer to 90 degrees. But that's for a different lesson. Okay, C and D. D, ooh, can't tell you yet. How about cosecant of 209.9 degrees? Okay, how about this one? Oh, cosecant. On your calculator, we do not have a button called cosecant. So 1 over 1 divided by, technically 1 divided by sine of 309.9. And we get ourselves that right there. So negative 1.3035. Negative 1.3035. Ah, interesting. So in Trig, Unless you're in tangent, which is very rare that you go into the thousands place, right? We normally like to keep it as 4 decimal places. So if they're not big, humongous numbers, we just go with that right here. So negative 1.33035. Cool, okay. So now, oh, interesting. Okay, let's go this way now. D, E. So let's do an easy one here. Let's do, yeah, we can do it this one here. So I need a sine of 30 degrees. That's easy enough. Let's graph it as well. Isn't 30 degrees right here, quadrant 1? Yes. Cool, sine 30 degrees is a half, right? On a calculator, it just said 0.5 probably, right? Okay, if you go over here, you're going to go sine of 150 degrees. Can you tell me what that one is? Oh, with your calculator, yeah. Sine of 150 degrees is? Yeah, we started doing this one here. So notice they're going to get the exact same value. Is that right? Whoa, okay. So here's our little problem, is that sine function of 30 degrees gives us 0.5. Sine of 150 degrees gives us that. Let's do this. I want to know what this is. I want to know sine of theta gives me 0.5. Oh, what? Oh, yes, we have to do sine inverse, right? Whenever we are trying to figure out our angle measurement, we always do this. So if you punch into calculator, what gives you that? Oh, interesting. It gives us not the 150, it only gives us the 30. How about said another way? Say it again. Our calculator gives us reference angles. That's what it does. So if we want to go backwards, we actually have to figure out how to get the reference angle and then go backwards in it. So yeah, but I want to show you give the same answer both ways, but your calculator, yeah. But then here's our little problem here. Example, what are we on now? Example 4. Ooh, new stuff here, guys. New stuff here. Example 4. Ready? Use a calculator. Use a calculator to find the answer to the, that's supposed to be a 2, to the nearest tenth of a degree. Oh, that's cool, not minutes and seconds. And then I have a condition upon theta. When 0 degrees is less than theta is less than 360. So don't give me above 360. I want to stay between 0 and 360. Say again. Yeah, and then we add 8. We add 360 or subtract 360, right? But we just want the angle itself. I want it to be 1 rotation only. All right, so A, here we go. Those are the calculator. And cool, good job. Those are standing up and getting a calculator real quick here. You guys didn't have it. So answer is, I need to know this. I need to know theta. If this is the case. Oh, I have to tell you which quadrant we're in, because this one's only going to be in the first quadrant, right? And I'm going to be in quadrant, 2. I need to know sine theta, giving me a 0.7314 in quadrant 2. So notice to the nearest tenth. So if we punch this into calculator, dun, 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 what you guys get for the answer on the calculator? Sorry, say that again. 47, sorry. 47.0. That's cool. Okay, some notation. You guys ready? Some notation. When you punch this in, when you write this in, you're going to write like this. Why are you going to write like that? Why are you going to write that? Because calculators give you reference angles. We good? So you only got a reference angle of 47 degrees. But if that is the case, we're supposed to be in quadrant 2. There's my angle. There's my rotational angle. And this is 47 degrees. So can you guys go backwards here? What is the degree itself? Oh, yeah. So you guys can do it in your head, right, if need be, right? Or we can create a formula. Oh, formula is in quadrant 2. How do we get back to our angle itself? Okay, 180 minus theta hat. Cool. Okay. Answer is 133.0, right? I guess, right? Boom. Are we good there? So we did the forward way of doing reference angle, and now we're doing the backwards way. So now, one more. You guys good? B. Well, let's do cosine. Cosine of point, I don't know, 4545, just because they're kind of fun little numbers. And I'm going to go in quadrant 4. Cosine theta. Let me give you all the rest of the information here. Go. So when I do this here, I'm not going to put theta here. I'm going to put theta hat cosine inverse 0.4545. Now, we actually will learn a whole bunch more, just so you guys know. We're going to learn a whole bunch more about this inverse stuff when we get to the end of chapter 4. That's when we're like, oh, that's the big picture. We're just doing some quick stuff here. All right, what'd you guys get for a reference angle? 63.0? I'm getting them pretty good here. Anybody else did not get 63.0? Got something different. On your calculator. Oh, boom, boom. Oh, got to turn my calculator on. Yeah, cosine inverse is this little guy right here. So you have to press the yellow button first. Boom. And it's 0.4545. Oh, nearest 10th. That's fun. Nearest 10th is a 9, right? Because there's a 6 behind. So the 9 becomes that, and then you got that, and then you got 16. Okay. We're in quadrant 4 right over here. Our reference angle is 63. And I need this angle. Oh yeah, you still round it. So the 63 and you put a 0.0 because it goes to the tenths of the 0 points. Yeah. Okay, so give me the formula. If I'm in quadrant 4, what gets me 63 and then gets me what I need from here? Perfect, 360 minus theta hat. And in this case, 360 minus 63 is? Second? 297, thank you. Okay. Get more complicated, of course, because it's fun to get complicated. Next, C. Oh, this would be fun. Secant. No, let's not do secant. Sorry, those are the pins. Let's do cosine first. Cosine theta, but I'm going to give you a little wrench in it. It's going to be a negative 0.2510. And we are going to be in quadrant 3. Now, real quick here, just to make sure we do this together here. So what you're going to do is you're going to forget about the negative. Because remember, we say reference angle, right? Reference angle is always positive, always in quadrant 1. So what we do is if you want to write notation correct, what you do here is you go like this. You change it right here. You say, hey, I'm not going to find an angle measurement. I'm going to find my reference angle measurement. And then I'm going to go here. So one little extra step, just drop the negative sign. Boom, 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 boom. Dropping the negative sign because you just want the reference angle. The negative of your negative 0.2510. And the angle measurement is 75.46, so 5 degrees, perfecto. We're in quadrant 3. Roomp, roomp, roomp. Since we're in quadrant 3, what's my formula to get us back to my angle measurement? Let's do it over here. 3. That's going to be 180 plus theta hat. Okay, cool. Do that. Boom, boom. And for this particular one, my angle measurement itself is going to be 180 plus. Sorry, hold on. Say again. 255.5, is that right? Yep, just making sure 255.5. No, angle measurements will be positive because it's this little guy right here. Right there, boom. I forgot my little arrow. Oh yeah, so that's easy. Yeah. So what we do is we go like this here. We just go counterclockwise. We go this way, Ava. We go clockwise, and that gives us a negative angle. Now, oh yeah, sure. It is hypothetical. So,
That's weird. It's kind of pointless. It's the exact same thing. It's just arrow in the other direction.
for computational purposes, yeah, but if you measure something, right, you're surveying, right, you measure from here to here, you're going to measure 135 degrees. If you measure from here to here, you're still going to measure 135 degrees, right, when you're surveying stuff. You're still going to do a positive sweep if you're going to do underground. But for calculation purposes, we stick negatives. So negatives are hypothetical things. We good? So that's why, oh. Uh-huh. No.
Well, yeah, but like the thing with the angles is literally the only thing making it negative is that little squiggly arrow. But like in the number line, if you want it to be negative is on the other side. That's why there's absolute values. Just like there's references. Negatives are always hypothetical. But then if it's negative 135, it's positive whatever the other thing is. Well, I think so. If you go this way and it's like 90 degrees, and then you can go back 30 degrees, and that's going back. Taking away the angle. I think it works. But then how is it different from other negative numbers? I guess my question. Because all negative numbers are hypothetical.
Cool, good job, Layla. Yeah, absolutely. All negative numbers are technically hypothetical numbers. They're used for computational purposes.
Why is the only thing deciding that it's negative is that little swoopy arrow? Like, it's just purely quantum. Yeah. Yeah.
So cool. So it's for computational purposes only. Negative numbers also for computational purposes, right? So it's the way you move across a number line, right? If you say 3.
The angle is the same.
Yeah.
Well,
interesting.
you might get a different, like, it's not like a positive number versus a negative. You can use the absolute value of the negative number the same way that you use the positive.
Remember, guys, the number line, eh? So whenever we added negative numbers, all it is, this guy just gave us, yeah. So.
I feel like you're not correct because all of math
I'm gonna save that debate for another day.
They're not.
Oh, you know what? Let me do something different. No, it's still for native fathers. Yeah, math and number line is universal. All right, guys, I think we're going to have to just have a duel one day, and then we'll solve it that way. But for now, let's go to exercise 5. Exercise 5, I'm going to throw a wrench in our situation here, so I need sine theta is equal to 1 over root 2. And I need to do it without a calculator, and we're in quadrant 2. Oh, cool. So what's up with the 1 over root 2, first of all? It is not rationalized, is that right? Yeah. So remember that this guy here can't put a root 2 on the bottom. Cool. So this guy's not rationalized, right? So in order to rationalize it, we're going to do this. This is root 2 over 2, right? So 1 over root 2 is the same thing as root 2 over 2. And is it sine 60? So I'm looking for this. Is that 60 or is it something else? It's 45. So we go like this. We say theta hat is equal to sine inverse of root 2 over 2. And the reference angle is in 45 degrees, but we don't want the reference angle. We want the exact answer in quadrant 2, which is quadrant 2. The equation is, it is 180 minus theta hat. In this case, 180 minus 45 is 135, and we are done. I'll let you guys out early by 10 seconds. So you guys are ready for homework 3.1. We good? So that means, let's see, we finished Wednesday, so that means it is